All right, ladies and gentlemen, today we are doing systems of linear inequalities, which means as it shows up there right there, we're going to be graphing two lines, so two inequalities. So it might be two solid, two dash, one of each. And we're going to have double shading. And it says right there, this double shading is called the area of solution. So with your highlighter, we're really going to focus on that area of solution. And what that means, again, is that whatever points are in that area of solution would be true for both inequalities, both lines. So we're going to do 4 together on your worksheet. The good news, again, is it's really just like you're going to be doing one line, and then you're going to do your separate line. So I'm going to go ahead and do two different colors. One thing you can always start off with, of course, is dashed and solid. So on your quiz, you're going to have a free response question like this. You're going to have some matching questions for multiple choice. And again, you're using your skills based off the last few days, today and Monday, of course. All right, so let's do the dashed line first. Again, this is already like y equals. So I'm going to go ahead and say for my first line, m is equal to 1/2 and b is equal to -1. So I'm going to split it up into left side, right side, wherever you can fit your work. If you have to use a scratch piece of paper, that is perfectly fine as well. All right, so it's ready to graph. Start at -1, up 1, right 2, up 1, right 2. So again, same skill that you were doing. Let's go ahead and line it up and make our dashed line. Something like this. I'm going to take my highlighter, origin. I'm going to test the origin with my original problem. So again, that is 0. Let me write that down real quick. Test 0, 0. On the original problem, again, it's 0 is greater than 1/2 multiplied by 0. Subtract 1. 0 is greater than 1/2 times 0 is 0. 0 subtract 1 is -1. So it says 0 is greater than -1. That is true. So for this first line, again, the shading is going to be true. I'm going to label it really small over here. Y is greater than 1/2 x, subtract 1. All right, so if you notice, that's exactly what you've been doing for 2 days. Now, just for mine, I'm going to change color and talk about my solid line. So again, that is m equals 2/1, and b is equal to 2. So my starting point is here at 2. I'm going to go up 1, 2, right 1. I don't have enough room there, so I'm going to go backwards, down 1, 2, left 1. Do it again if you want. Down 1, 2, left 1, down 1, 2, left. And again, this is a solid line. Now, I can still use the same highlighter dot if you notice. Or you can change a color if you have a different color you want to use. Whatever. But again, you're still using the origin. But notice where the origin is located. So I'm going to go ahead and test the origin again. So test 0, 0. I'm on the original problem. 0 is greater than or equal to 2 times 0 plus 2. 0 is greater than or equal to 2, and that is false. So for my blue line, your second line, I got a false statement. So again, I'm going to go ahead and do my shading. And it was false. All right, so last thing that I want you to do is with your highlighter, once you realize where the area of solution is again, and again, that's where the double shading is. So that's why I chose two separate colors for our instruction. is you can see where the black and the blue shading crosses each other. Now, sometimes you get nice boxes, sometimes you get diamonds. Regardless, you should have it crossing. It's where both are going to go. So with your highlighter, you're going to go ahead and let me zoom in a little bit better. Along the lines, let me expand the size. Not still going with the blue because again, over here is the black line. So everything over here is considered the area of solution. Because again, that's where the black and the blue are crossing. Again, I did not go down here because that's where the black line, the first line, started. So right here kind of is where the point of intersection would be. We've done that before. But again, I'm looking for the area of solution. So let's talk about the area of solution a little bit more specifically on how you're going to see it on your quiz. You are going to have some free response questions like this, but also I might have a question asking this. That's why I got all funky, silly, Mr. Maria. I forgot to change it to the highlighter. That's a little bit better. Okay, now I know what's going on. Okay, so the question might be something like this. Is 0, 5 a solution of the system? So solution of the system means it's on the area of solution. So let's look at 0, 5. So 0, 5 again is starting at the origin, not moving left or right, but it's going up 5 spaces. And 0, 5 would be right here. So according to your area of solution, is this point of 0, 5 a solution? Well, it's in the double shading, it's in the highlighter area, so therefore it would be a solution. What about the same question, maybe a different point? What about 2, 3? Is 2, 3 a solution of the system? 2, 3, again, is 2, 1, 2, 3. If you notice here, it's only where the black shading would be. So therefore, 2, 3 would be a true or a solution of my first line, which I represented by the black color here. But it's not a true statement. It's not a solution of the blue line. So is it a solution of the system? This one would be no. So the area of solution, the highlighter, is really the key. So if the point is in the highlighted stuff, then it's true. Yeah, that's a solution. But if it's not in the highlighted stuff, it would be not a solution. All right, so let's talk about this one. So again, I'm going to represent it as 2 separate colors. So for my first one, again, that would be a solid. Second one would be a dashed. So on my solid line, again, I'm going to think of y equals -2, and I'm going to make a t-chart. Again, all the y's are -2. X is 1, 2, 3. All right, go ahead and graph that really quick. All right, so I would go right 1, down 2, right 2, down 2. So it's going to give me a nice, solid, horizontal line. I'm able to test the origin. So according to the original problem again, that would be 0 is greater than or equal to -2. That is true statement. For my first line, I'm going to shade here. Again, we get close, but we don't pass the line. Y is greater than or equal to -2. All right, my second line is dashed. It's already ready for me for slope of 3 over 1 and y-intercept of +1. Up 1, 2, 3, right 1. I don't have enough room, so I'm going to practice my backwards thinking. Down 1, 2, 3, left 1. There's the point of intersection. Do it again. Down 1, 2, 3, left 1. And again, this is a dashed line. So again, this is really just a repeat of what we've been doing on Wednesday and Thursday. Again, I could label it right away if I want to, just at the edge. Y is less than 3x plus 1. Again, I'm going to test the origin. I notice that it's really close to the origin, but the origin is not on the line because it does not start at the origin. So with my original problem for testing 0, 0, again, I have 0 is less than 3 times 0 plus 1. So I have 0 is less than 1. That is also true. So again, I'm going to shade the side with the origin for my blue line. That would be this side. Let's talk about the area of solution a little bit more specific. Our areas are broken up actually into 4 parts. This part over here, if I were to test it, that would be no solution or false for both inequalities. If I were to test this one, it would be a solution only for the black line, which is my first one, the horizontal one. It would be a false statement for the blue line. Here, again, it would be a solution for the blue line only, not the black line. But over here, all of these points again, that would be solution for both inequalities. So again, the way we finish that off is we take our highlighter, we get real close to the line, we stop at the line, and we essentially say that again, this is our area of solution, which means every single point in there would be true for both lines. Again, blank area, false for both lines. Black shading, true for only the black line. Blue shading, true for only the blue line. Double shading, true for both lines. So again, you could test a point. So if you were to talk about 2, 3, 2, 3, yeah, that's in the double shading. If I have 2, -5, 2, -5 down here, that's only true for the blue, so it's not true for the area of solution. It's got to be in the highlighted part. All right, let's try 2 more. And again, these are the problems that require a little bit more work. First one is dashed. Second one is solid. Oops. So first line, going to bring it over here. 3x subtract 1y. And I'm going to think about equal sign, -2. I'm going to put a line segment down here to separate my work between the 2 lines. So again, move the x. And divide. So it gives me y is equal to +3x plus 2. So m is equal to 3 over 1, and b is equal to 2. So starting point again is at 2. I go up 1, 2, 3, right 1. Looks very similar. Down 1, 2, 3, left 1. And this is a dashed line again. You can label it on the original right now. 3x subtract y, and that's going to be greater than negative 2. With your highlighter, test the origin. Remember, you're testing the original. The original, again, is 3 times 0, subtract 1 times 0, greater than negative 2. So 0 is greater than negative 2, and that is going to be true. So since it's true, I shade the side with the origin, with the highlighter. Again, just a repeat. We've done this work. We're just putting two lines together. All right, my solid line now. I think about the equal sign. I subtract 2x. Now wait a minute. 1y, that's really just y. So I'm really not going to have to divide on this one. But if you wanted to, if you divide by 1, it really doesn't help or hurt you. So, but I'm recognizing, again, 1y is just y. I'm good to go. A little bit less work. M is equal to negative 2 over 1. And b is equal to negative 3. So starting point is here. My slope tells me down 1, 2, right 1. Again, here's my starting point. Down 1, 2, right 1. Backwards is up 1, 2, left 1. They share a point. That's the point of intersection. That's what we did back in chapter 5. Up 1, 2, left 1. Up 1, 2, left 1. You can do it again if you want to. I know some of you make your line all the way over. This is a solid line. I'll give you a moment to catch up before we test our origin. All right, so for the blue line, the original, the solid, we're going to test 0, 0. That's 2 times x, 2 times 0, plus 1 times 0 is less than or equal to negative, whoa, it's supposed to be negative 3 right there. So 0 is less than or equal to negative 3. True or false? That is false. So for the blue line, I'm going to shade the side without the highlighter, without the origin, which is this way. Again, if I want to label it here, 2x plus y less than or equal to negative 3. All right, so again, 4 areas. We have no shading, false for both lines. Just black shading, true for the first line. Just blue shading, true for the second line. And again, our area of solution that we want to focus on is where the double shading occurs. Again, this means that every point in this area is true for both lines. Again, it's called the area of solution. All right, let's do one more. All right, first one is solid. Second one is solid. Oh, good. I like those better. Put some ones if it helps you. Number 10. So my first line, again, I think about the equal sign. Subtract 1x. Divide by 3. Same skills from November. And it's going to be a subtract 2. So my slope is negative 1/3, so it is going downhill. And b is equal to negative 2. So I start at negative 2. Go down 1, right 3. Down 1, kind of right 3. Reverse, or backwards, up 1, left 3. And yeah. All right, solid line. We're going to test the origin on the original, remember. So I have x, which is just 0, plus 3 times 0, less than or equal to negative 6. So it's just 0 is less than or equal to negative 6, and that is a false statement. So for my black line, the first line, I don't like that pair of shoes, so I'm going to come over here to the other side. Again, it's not scribble shading, not art shading, it's just simple line segments. So again, that is x plus 3y is less than or equal to negative 6. All right, second line, also solid. I have it as 1x subtract 1y is less than or equal to negative 2. I'm going to subtract 1x, both sides. So that's negative 1y is less than or equal to negative 1x subtract 2. Divide everything by negative 1. Oops, that's supposed to be equal signs. So y is equal to, a negative divided by a negative is a positive x. Negative 2 divided by negative 1 is positive 2. So m is 1 over 1, and b is 2. So starting out here at positive 2, I go up 1, right 1, up 1, right 1. Go reverse if you want to, or backwards. Point of intersection. Let's make our solid line. Label it. X subtract y is less than or equal to negative 2. We're going to test to see if we get a true or false statement. On the original problem again, it is x subtract y is less than or equal to negative 2. So 0 is less than or equal to negative 2, and that is false again. So for my blue line, I don't like that pair of shoes, so again, I'm going to shade on the other side. Side without the highlighter, without the origin. All right, last thing again, our area of solution. It's where the double shading is occurred. So let's zoom in so you can see it a little bit better. Over here on the side. Now, there are some more advanced problems that you will discover in high school. Those involve the parallel lines. So instead of 4 areas, meaning a no solution, single, single, and then double solution, meaning the area of solution. If it's parallel, you'd only have 3 areas. All right, you have your remaining time for your homework. Be awesome.